The vast universe is a stage for the birth, life, and death of stars in spectacular ways. One such star, Betelgeuse, has recently captured the attention of both astronomers and the public. This colossal and ancient star has always been noteworthy for its reddish hue and fluctuating brightness, but recent developments have intensified our fascination. Using the powerful James Webb Space Telescope, scientists have made a troubling discovery about this massive celestial object, and renowned physicist Brian Cox has even issued a grave warning. On March 14, 2024, the American Association of Variable Star Observers reported that Betelgeuse has dimmed by about 0.5 magnitude since late January. As a variable star, changes in its brightness aren't unusual. However, Betelgeuse is now dimmer than it has been in several years. Is it possible we're witnessing another great dimming of Betelgeuse similar to the one in 2019? If so, does this indicate instability in this old red supergiant star? And could it mean Betelgeuse will explode soon? Betelgeuse, a staggering 764 times wider than our Sun, is a true stellar giant. Its size is almost unimaginable. If swapped with our Sun, Betelgeuse would engulf everything out to Mars' orbit, swallowing Mercury, Venus, and Earth in its fiery embrace. This immense scale isn't just awe-inspiring, it reveals Betelgeuse's life stage. At a mere 8 to 8.5 million years old, Betelgeuse is a youngster by stellar standards. While this may seem like a vast stretch of time to us, it's a blink of an eye for a star. Over these millions of years, Betelgeuse has undergone a dramatic transformation, evolving from a scorching blue giant to the colossal red supergiant we see today. Betelgeuse's signature reddish hue stands out as a hallmark of its current life stage. Unlike our Sun's scorching surface, clocking in at around 5,500 Kelvin, Betelgeuse is a cooler giant, radiating at a temperature of roughly 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light at longer wavelengths, giving it its distinctive red color. But beyond its aesthetics, this red color is a clue about what's happening inside this giant ball of gas. Betelgeuse has already burned through its primary fuel, hydrogen, and is now fusing helium in its core into heavier elements. When a star runs out of hydrogen, it must put extra energy into igniting the helium produced during the fusion of hydrogen, which forces it to expand dozens of times beyond its original size. In the process, it also becomes cooler and redder. The story of Betelgeuse's color adds another layer of intrigue. Historical accounts from Roman and Chinese observers described it as yellow roughly 2,000 years ago, while by the 9th century, Arabic astronomers noted its transformation to red. This remarkable shift isn't just a footnote in scientific history. It's a testament to Betelgeuse's dramatic evolution. Betelgeuse is not a steady light in the sky. It varies in brightness. Classified as a semi-regular variable star, it follows predictable cycles of brightness fluctuations. This has fascinated astronomers and sky watchers for centuries. In 2019, astronomers noticed the star dimming significantly and supposed they might have been watching a precursor to the Big Show. Instead, over the next few months, Betelgeuse quietly returned to normal. This event, named the Great Dimming, saw Betelgeuse rapidly lose brightness, shedding light at an alarming rate. By February 2020, it reached its faintest point, a noticeable change even for casual stargazers accustomed to its brilliance despite light pollution. Analysis of images taken before, during, and after the Great Dimming event revealed that Betelgeuse didn't actually get any dimmer. It just appeared so because we were looking through a cloud of stellar debris. Astronomers realized that while the amount of light we were receiving decreased, the amount of light in the photosphere of Betelgeuse ramped up. The light they studied had lines of magnesium in it, like a fingerprint. This fingerprint showed them a surprising thing. A giant cloud of hot gas was thrown off the surface of Betelgeuse into its atmosphere at an incredible speed, like a super-fast car going 200,000 miles per hour. This super hot and thick material traveled millions of miles away from Betelgeuse and puffed up into a giant cloud of dust. This dust cloud is what caused the star to dim for about 3 months. Dr. Dupree's team thinks Betelgeuse blew out about twice the usual amount of material, mostly from the bottom half. All stars lose some material over time, but Betelgeuse lost a whole lot more and way faster than our sun. This giant puff of dust and the dimming made scientists wonder if Betelgeuse might explode someday. Since Betelgeuse is relatively close, only 725 light-years away, an explosion here would be incredible to see from Earth, like a super bright fireworks show in the night sky. While it may not have been a warning shot before Betelgeuse goes supernova, the event is teaching us more about how stars lose mass and evolve toward the end of their lives. Although Betelgeuse has since recovered its usual brightness, the star has not been quite its old self since the Great Dimming. Its 400-day brightness oscillation period has halved to 200 days, and on top of that, the star now appears to be going through extra brightening phases that excite sky watchers. While a star's regular life ends when it runs out of hydrogen and begins to fuse helium in its core, its expanded life as a red giant lasts beyond the helium burning stage. With helium gone, the star will sustain itself by burning carbon and oxygen into neon and magnesium, then burning those into silicon. Eventually, the star's core fills with iron, and that's when the fireworks begin. However, the vast distance of Betelgeuse, some 725 light-years away, presents a cosmic challenge. The starlight we see today actually left the star nearly 700 years ago. This time paradox makes it difficult to observe Betelgeuse in real time, adding another layer of intrigue to this celestial whodunit. Because of this delay, it's hard to know exactly what's happening right now on the star. The dimming of Betelgeuse reminded us that it's difficult to see things in space as they happen. It's like looking at a giant puzzle with missing pieces. But let's be clear, the history of supernova observations within our own Milky Way is sketchy. Of course, we'd surely be lucky to see any galactic supernova, especially one as close as Betelgeuse, in our lifetimes. The big question is, will Betelgeuse explode someday? There's been a noticeable uptick in Betelgeuse's brightening and dimming since 2019. A paper published in June 2023 suggested not thousands of years, but tens of years as the timescale for Betelgeuse going supernova. Scientists are sure that Betelgeuse is a good candidate for the next galactic supernova. Whenever Betelgeuse does blow up, anyone alive on Earth will see an amazingly beautiful sight in the night sky. A very, very, very bright star. Professional astronomers will be happy to have an exploded Betelgeuse so close, as they'll be able to study the star post-supernova. It won't harm our planet, much less destroy life on Earth. Studies indicate we'd have to be within 160 light-years of a supernova for it to harm us, and Betelgeuse is perhaps 4 times this distance. Meanwhile, amateur astronomers and casual stargazers will enjoy the explosion too. But many who enjoy seeing Betelgeuse as Orion's bright red star will dearly miss it when it's gone.